Global warming has been a huge issue within the 21st century. Thousands of metric tons of greenhouse gases are being emitted, which is affecting the oceans, which includes the sea levels rising, the environment, and our human bodies and health. Luckily, we have technology called scrubbers, which will help us reduce the amount of greenhouse gas emissions and help protect our environment and ourselves.
So, what are scrubbers? Scrubbers are a form of technology designed to efficiently and effectively remove gas pollutants using the phenomenon of absorption before they can reach the atmosphere. These pollutants include ammonia, chlorine, and sulfur compounds.
Dry scrubbers are primarily used to remove acid gases, such as hydrochloric acid and sulfur dioxide, from combustion sources. There are two main sections of a dry scrubber: a device to mix a sorbent material with the gas, and another device to remove whatever products result from the reaction. The scrubber starts by cooling the emission gases to make it easier to remove the pollutants. Cooling the gas dilutes it. After the gas has been cooled, the reagent is introduced to the gas. Since this is a dry scrubber system, the reagent is usually a dry substance with neutralizing properties, such as sodium bicarbonate, soda ash, or hydrated lime. This reagent is fired at high pressures into the gas, and the resulting reaction neutralizes the acidic gas and removes the harmful pollutants. Finally, a fabric filter gathers up the used scrubbing powder, and the clean gas is released back into the atmosphere. Here is an example of an acidic gas that is neutralized through a dry scrubber system. The acidic gas being examined here is sulfur dioxide. Sulfur dioxide is harmful to the environment because of a harmful product it can create once introduced to the atmosphere: sulfuric acid. This reaction shows how sulfur dioxide first mixes with oxygen to create sulfur trioxide, the reaction intermediate, which is then mixed with water to create sulfuric acid. Sulfuric acid, once exposed to UV radiation, can result in acid rain. Fortunately, this sulfuric acid can be neutralized with a semi-dry scrubber and a mix of lime and water, as shown in this multi-step reaction. The end product of this reaction is a harmless substance, gypsum, which is used in drywall, cement, and as a component of fertilizer.
Now for wet scrubbers. Wet scrubbers are primarily used for cleaning air, gas pollutants, and fuel gas. They work by dissolving or absorbing the pollutant into a scrubbing liquid. The scrubbing liquid depends on the properties of the pollutant. Some examples of possible scrubbing liquids include sodium hydroxide and magnesium oxide. Similar to a dry scrubber, the wet scrubber passes the harmful gas through a device with the aid of fans. Once the exhaust gas enters the chamber, the scrubbing liquid is pumped into the device and misted inside. When the gas mixes with the scrubbing liquid, the heavier pollutants are pulled out and attached to the liquid. The liquid residue is then filtered out at the bottom of the chamber and collected to be treated and disposed of separately. The clean gas is allowed out of the scrubber and released back into the atmosphere. Large concentration amounts of ammonia can heavily damage the respiratory tract of the human body when inhaled. This includes the burning of the nose and throat, and also the destruction and failure of the respiratory system. Ammonia in normal amounts is not harmful to the environment. However, in large concentrations, it can be very dangerous due to the fact that it can cause severe damage to aquatic life. Through a wet scrubber, ammonia can be neutralized. It is mixed in with diluted sulfuric acid to create ammonium sulfate, a harmless substance that can be used as a plant fertilizer. The chemistry behind scrubbers! First, we have a graph depicting the reaction rate of sulfur dioxide with hydrated lime. The concentration of the dissolving sulfur dioxide is given in micrograms per milliliter, and the time is in hours. First, we're going to be looking at reaction rates. Here we have a graph depicting the reaction rate of sulfur dioxide with hydrated lime. The concentration of the dissolving sulfur dioxide is given in milligrams per milliliter, and the time is given in hours. Examples of collision theory can be seen in both dry scrubbing processes and wet scrubbing processes. In wet scrubbers, different nozzles are used to mist in the scrubbing liquid, changing the total surface area of the scrubbing liquid and also changing the rate of reaction. In dry scrubbers, the temperature is also changed to cool down different acidic gases to make it easier for the dry scrubbers to filter out the harmful pollutants.
Let's look at this reaction and see how Vesper theory applies here. Calcium hydroxide, commonly known as lime, is a bent molecule with hydrogen bonds. Sulfur dioxide, on the other hand, has dipole-dipole bonds. This means that it is much easier for the calcium hydroxide to break apart sulfur dioxide. In conclusion, scrubber technology is essential in helping us reduce the amount of greenhouse gas emissions in the atmosphere, as well as protecting the environment and ourselves from harmful acidic gases. Thank you so much for watching.